Our next speaker actually is going to address some of the last question that was brought up. What is the economics of biosecurity? And so our next presenter is Dr. Karyn Havas. She is with Pipestone Research, and she's a veterinary epidemiologist for Pipestone in their research division. Her background is specifically transboundary animal diseases and currently has projects related to cost of disease in the wean to finish sector and antimicrobial resistance trends in swine. And so she's going to give us the early findings of evaluating disease introduction and biosecurity to the wean to finish sector. And so I think these two really are going in nice progression. Talked about how do we deal with structural changes and now looking at the economics of what some of our biosecurity implementations would be. So
great, thank you. Excuse me, I have like a frog in my throat. Yeah, so today I'd like to talk to you. We're not going to give you any cost of disease data today because we're just not there yet. We're just collecting the closeout data from some of our first oh yeah, great, thank you. From some of our first sites. But I'm going to share with you a little bit about this project that we're doing at Pipestone and then talk to you about some of the biosecurity findings that we've come up with so far. The sample sizes are not large, so if next year we come and talk about this again and it's different, it's because our sample size grew significantly, so just be aware. So we know, and if you were in the PERS session yesterday, we know that PERS costs us a lot of money. Right? It costs us $1.2 billion, and that's on data from 2016 to 2020, which leaves out the 144 L1C and 144 L1C.5. So even without that strain, it's costing us $1.2 billion. And the majority of that loss, thanks to the work done by Dr. Holtkamp there, is in the grow-finish sector, right? So, and we also have individuals or groups that recognize this problem and are trying to encourage improve biosecurity in the wean-to-finish sector through research, which is always great. So the Swine Health Information Center, Foundation for Food and Agricultural Research are funding a number of projects, including this one, to try to answer how can we do biosecurity better in the wean-to-finish, grow-finish sector. So, and to do our part, because we like to do our part, Boehringer Ingelheim and Pipestone got together and said, okay, I think we can put a cost to this because ag's a business and people like to know if there's a return on investment to their business. And so if you're going to ask a producer to put in an ante-room or a supply room or anything where they can do better biosecurity, the return on investment better be there. But we don't know what the costs are. Like we really don't know what the cost is at the farm level. We know what it is at the industry level. So $1.2 billion is one of those numbers you can't fathom. So if you say to a farmer, okay, this costs $1.2 billion, okay, I have no idea what that looks like. Oh, if you say to a farmer, okay, this costs you $100,000 or $50,000, that is now a tangible number they can make decisions off of. So that's part of the goal of this research is to give them tangible numbers to be like, this is what this is costing you in a budget that makes sense in any human's brain. 1.2 billion, no human, a billion things I can't even imagine, right? It's beyond comprehension. So what do we do? What are we doing? Well, we're going to follow about 200 weaned pig groups. And they're going to be placed from negative sow farms. And these sow farms are negative for swine influenza A, PERS, PEDV, and Mycoplasma pneumoniae. And if you were in the the keynote this morning, you'll know that we place 73% of our sow farms place 73% of the pigs influenza negative. And then I'll go ahead and show you in just a few minutes what happens when it gets to the grow-finish sector, right? So it's kind of a stark contrast. But the goal is to place the negative into the wean-to-finish sector, and then we sample them twice. And there are about 15 to 18 pig groups per 8 weeks, so we have it broken out so it's spread over the year. So every 8 weeks we pick about 15 to 18 pig groups to follow, and we sample them at 8 to 10 weeks of age and at 18 to 20 weeks of age. And the way we do this selection is we recognize that there's a density issue, right? So we want to kind of capture what's happening in the industry. So if I know that 50% of my pig groups are going to Iowa, 50% of my pig groups I select are going to be from Iowa. So we've tried to stratify it, and then we randomly select the enterprise. So if farmer A, B, and C are in Iowa, but I only need one site in Iowa, I randomly select the enterprise, and then I randomly select the pig group to one site from that enterprise. Because as we know, numerous producers have numerous sites. So we try to stratify it, then randomly select, And then we go back and say, okay, is everybody coming from one pig farm, from one sow farm, or do we have a good coverage of our sow farms? So there might be some modification going back and redoing some random selection to make sure we have a good diversity of sow farms so that we can kind of control for that factor as well. So it's a process. It's a process. We're on our 5th group, Group E. We're just doing that now. So this data I'll present today is through the end of July, early August. That was the last update we had that gave me enough time to do some statistics for you. So the sampling is, like I said, is at week 8 to 10. And at week 8 to 10, we do some oral fluid sampling. And we use fixed spatial sampling from Marisa Rotolo's paper in 2017, 2018. And we'll get either 5 to 7 oral fluids based on the size of the barn. And like I said, fixed spatial sampling, so throughout the barn. We also are collecting fecal samples. And the fecal samples are from the 6 pens, also fixed spatial sampling throughout the barn. So they're kind of equidistant from each other, going across the range of the barn, leaving out the sick pens, just to be clear. And it's from the dunging area. We just take little teaspoon scoops, throw them in a whirl pack, and we end up having about 25 to 50 grams of fecal material from these pens, from across the dunging area of these pens. And from that, and then at 18 to 20 weeks, we do the same thing, but then we randomly select one pig from 15 pens, again, equally spaced throughout the barn, to get a serum sample from. And with the serum sampling, we're testing for influenza, PEDV, Mycoplasma pneumoniae, Salmonella, and intracellularis. And from the oral fluids, in the first sampling, we're testing for PERS. In the second sampling, we're testing for PERS and PCV2. And from the fecal samples, Salmonella culture and Lawsonia intracellularis real-time PCR. And all of the testing is being done at Iowa State University, Veterinary Diagnostic Lab. It's important to note, so Salmonella, Lawsonia, PCV2, we don't know if we're placing them negative for those. Those we're trying to understand co-infections a little bit by including those into the study. But we don't know if we're placing those pigs negative for Salmonella, negative for Lawsonia, and negative for PCV2. Oops. Whoa, got away from me. Sorry about that. So you might go, okay, how did you choose these sample sizes? Little bit logistics, you can't spend $1 million, right? So people get fussy when you ask for $1 million. But we wanted to understand what we could afford to do and then what we could detect. And what we could detect, we think is reasonable. So the way this works is based on our sample sizes, what's the expected prevalence you detect? Well, if the barn has PERS in it, we expect that it'd be in at least 50% of the pigs. It's not a slow burn virus. It's going to go through pretty quick. So shortly after introduction, you probably expect at least 50% of the pigs. And our sample size will detect it if 50% of the pigs are infected. So that's what this is telling you. And you can go down the list and see. So for Salmonella culture, and we're using a different culture than is typically used. We're using all 25 grams of that feces, except for like a little bit for the Lawsonia PCR to detect Salmonella. So it raises the sensitivity up significantly by doing it that way. So we think we can detect if it's greater than 30% prevalence for Salmonella and Lawsonia. For the ELISAs, we think 25% prevalence. The Mycoplasma pneumoniae with some caveats about time since time post-exposure. We think it's about 35% prevalence. PEDV, antibodies 40%, and PCV2 50%. So early infection in the barn, probably not. Like if it's been in the barn for a little bit, absolutely. And that's one of the reasons we're testing at the end, the market age. And the ones we're testing early are either probably came along from the sow farm or it's PERS and it's going to be through the barn in no time at all. So there's some things to consider as we talk today. So MHIO is difficult. I'm learning. I'm not an expert on MHIO. So we have a bunch of suspect results, right? And what do you do with suspect results? The way we're classifying the barn is not like, 3 of the 15 were positive. We're saying the group is positive. We're not saying, 20% of our samples are positive and trying to figure out what that means. The group is positive, which is really easy with PCR, right? You get one of those 5 oral fluids is positive, group's positive, we're good. Because our goal is to detect freedom of disease and not prevalence of disease. Well, then you throw MHIO in there and it's got the suspect issue where It matters how many of the serum samples were suspect. It matters how long it's been since they've been vaccinated. So it gets a little more complicated. So really for this conversation, if I can't tease apart the non-vaccine positive, which we really can't at this point, I think we're quite close. I'm working with MHIO experts to do that, Amanda Sponheim and Eduardo Fano. They're quite good, and so we're working that out. But you'll see when we get to the mycoplasma discussion, I don't do too much discussion because we haven't yet teased apart based on the prevalence of suspects and the history of vaccination, if those barns are truly positive or if it's a response to vaccination. So just keep that in mind. And then we also captured a bunch of additional data because, disease data is great, but you need something to, metadata around it. Give yourself a picture, paint the portrait, if you will. And we have a lot of metadata, which I don't think we really appreciated when we started how much metadata we'd be collecting. And this is where a lot of the effort comes into for us, who's sit at the computers and not the guys who go to the barns. They're doing great work for us too. But we use a wean to finish biosecurity assessment at Pipestone. It's something we implemented a few years ago as a way to kind of give a view of what's happening in our wean to finish sector with biosecurity and where we can improve. And we give them a metric, and now we can benchmark and do all these things and take advantage of competition and say, oh, well, this guy's here and you're here. How do you get yourself here, right? Because it gives it a score. And it also gives a veterinarian an option to have those conversations and identify the weak areas using a tool. We also developed a questionnaire just for this project, and it covers a lot of production information. So how many barns are on site? How big are the barns? How did you start your pigs on feed? What kind of feed do you use? What kind of feeder do you use? What kind of ventilation do you have? How many caretakers do you have? So on and so forth. And the other thing we're doing with that is say, okay, do you double stock? Did these pigs in this barn come from a double stock nursery? Is this a wean to finish barn? Did it come from a single stock nursery and then go to a finisher, et cetera? So trying to capture some of this additional understanding that could lead to disease spread. We're also capturing all of the treatment records, all of them, from everywhere. So we have programs for our sow farms, and I can go and look that up really easily. When were the piglets treated? After farrowing, what vaccines did they get? What the dose of vaccine they got? I get that from our sow records. Then we can get the wean to finish records, treatment records from the barns or the nursery, and I go through each one of them and add them to a database. And some of them are really clear, and some of them you need a code. They're like, the blue pig. And you're like, well, what's the blue pig? And then they have this internal code. Well, the blue pig got these 3 antibiotics. And you're like, okay, all right. So you get a wide variety of what treatment records are. But we grab that and we acknowledge what's being treated, but not the amounts. And the reason is because there's not always amounts. Particularly for the injectables, they're not saying I gave 0.5 cc's to 5 pigs. Sometimes it's not legible, or it's not clear, or it's handwritten, or it's smudged, or something like that. So I have information based on when they get what antibiotic they gave, if they gave it before the first sampling or they gave it before the second sampling. But that's the extent of the detail I can get on that. So you'll see we're not including that in our closeout data. So we get the treatment records, we get the feed medication records, and all the vaccination records that are available. So we're collecting a lot of data, and we have this massive database. So and for the closeout data, we're looking at mortality, percent full value. We're trying to look at average daily gain and the feed conversion. Our goal is to absolutely include the mortality and percent full value carcasses because we know that's reliable. We've enrolled farms with data that we know is reliable, and we're going to see if we can also get average daily gain and feed conversion and carcass weight. Excuse me, I don't think that's up there. And the average carcass weight. If we can ensure that it's consistently reliable. So very complicated project. It's probably one of the biggest data gathering projects I've done, and it's been interesting so far. So this is what our wean to finish questionnaire assessment looks like. It's not complicated, and there's a point to it not being complicated, right? There's 19 questions. You can get 0 points, 1 point, or 2 points. 0 is bad, 2 is good. And the highest score you can get is 38. And that's it. That's all we do. And it allows for conversations. And it has, I think, 9 different topics. So location, animal entry, single-age sites, feed, animal transport, mortality management, supply entry, personnel entry, site sanitation, and training and auditing. So just the biggest picture possible, but allows us to have an idea of what that biosecurity looks like. And then we have this project questionnaire. And then we fill this out at the barn, like I said before, kind of went through it, just so you could see what it looks like. It's 2 pages, it's probably a little too long, but we do also try to collect some of the disease data. So did they vaccinate in the barn? Did they have any diseases that popped up? And if they did have a disease, did they diagnose by clinical signs, or did they diagnose with diagnostics? So I think if you're in the swine industry today, you might know that we get a lot of flu, but not a lot of people are necessarily gonna send in that flu for testing at the moment, right? If we're honest. Right? So we want to make sure we capture it even if they didn't send in diagnostics. In the past few years, with the cost of diagnostics, people were like, well, it's flu. I'm not going to spend a couple $100 for the diagnostic lab to tell me when I'm losing $20 a pig. So there's all these dynamics of, okay, well, let's get the assumed disease diagnosis as well, even if there's not diagnostic testing. But it's all verbal. It's all oral. So, you know, there's a plus and minus to our system here. So what am I going to show you today? So I'm an epidemiologist who likes statistics. Can't help myself. And people use parametric statistics too much, so I thought I'd show you guys some non-parametric approaches. So I'm going to show you some of our biosecurity scores off that questionnaire that you saw, or assessment, based on disease status, where possible. And I use a non-parametric approach, which looks at the range of data, not just the median, but often people say, oh, I compare medians. Well, you don't. You compare the range. But the median is, you know, the center of the data, the very center. Every time, no matter what, the mean is not, the median is. And that's what I'm going to show you today. Like I said, that actual cost of disease, you know, check back next year. We'll have some data on that. We're excited to get that done, but we only have, I think, 19 closeouts in the database right now, so it takes some time to grow some pigs and get those results back. All right, so let's dive into the fun part, right? All right, I used some color coding, because this is a lot. Maybe I should have made different tables, but this is what we got. So in this one, orange is nursery and blue is finisher, okay? And what's kind of interesting is, well, the next slide I'll talk about what's interesting, but the finisher sites had lesser biosecurity for truck and trailer biosecurity overall, mortality removal and power washing compared to the nursery, statistically. Okay? That's what we see with 28 nursery and 49 finisher results. And those nursery assessments are also done. So often our veterinary technicians, our veterinary physician's assistants, as we call them, they'll do a biosecurity assessment to finisher, and they have to go and do it at the nursery. So we get it at both sites, even though we're not sampling in the nursery. Right? 8 to 10 weeks of age is just past nursery. The nursery site had lesser biosecurity for ages on site and all in, all out. So that's that crude comparison of wean to finish biosecurity. Where are they different? Based on early results using non-parametric statistics. And I used a very liberal, I know everybody likes 0.05. I did not use 0.05, I used 0.1. Give us a little more leeway. I'd still bet on something if I was 90% confident, right? So that's still a good go. So when we start talking about disease status, like this is PRRS, and we start to tease apart some different things. Now those colors are going to be different. So now orange is going to indicate that biosecurity is not protective, because I didn't know how else to word that quite yet. So having a higher biosecurity score, you had higher disease. Remember, a higher biosecurity score means more biosecurity. So I'm kind of excited to tease this out and think about it a little harder and talk to people about it. So if you have any thoughts, please let me know. And the blue indicates that biosecurity is protective, which is the preferred solution, right? That's what we want. So with PRRS overall, we had about 72% of our farms are positive for PRRS as you go through. On the first sampling, 36% were positive. On the second sampling, 66% were positive. This is without the vaccine. So we in our testing, not only do we do PCR, but there's obviously OR5 sequencing, and then ISU has this great tool where you can load it in, and it tells you how related it is to vaccines. And we're also using a clamp assay to help further elucidate that, to make sure that if the wild type doesn't get masked by the PCR, right? So that we can make sure we grab the, the wild type and not a vaccine if the vaccine's in there. So we have a lot of numbers, and when you look at nursery and you look at finisher, for whatever reason, the second sampling, and I don't know why, right? I have no answers for this yet. I haven't, like first sampling versus second sampling, why it's different. But in the second sampling, for some reason, biosecurity is not protective in the nursery. In the first sampling, biosecurity seems protective. It's weird. I don't know, right? Don't know. And maybe it means nothing. Maybe it's just a random finding. We're not sampling in the nursery. Yet you go to the finisher, and in the overall, biosecurity is protective. And in the first sampling, biosecurity is protective. I'm also sampling in the finisher. This makes sense. Like this, you know, the different reasons for causality, this makes sense. Like logically, this makes sense. We can draw the line, we can do all those things. Time to event, feasibility, all of that's in it being protective. So very comfortable with those results. So let's break it down though. That's a big, that's on the overall score, but is there some nuance to this? And yes, there's a little bit of nuance. And I summarized, you know, so you don't have to try to piece this apart. I summarized over here. But basically, in the nursery, having a lower regional pig density is protective. That's not surprising. Good, and we know that, right? Regional pig density makes a big deal. Not protective is truck and trailer wash and disinfection and mortality removal. So I'm not quite sure what to do with that. Now, the trucks coming from the sow farms in Pipestone have a significant biosecurity component to it. So maybe there's just, I'd have to go back, maybe there's not enough variability to tease it apart, right? So there's some things there that I kind of wonder about. But the trucks coming from the finisher could be anything. Those aren't our trucks, we don't control them. So that has its own biosecurity that's independent or dependent upon the producer's protocols. Now for the finisher, all the things you think would be protective are protective. Having good pig health on arrival, having good truck and trailer wash biosecurity, being in areas with lower pigs, a lesser pig density, being in areas where not a lot of sow farms bring pigs to, and the overall score. And when I say pig health, we have this pig health pyramid where you're red, yellow, or green. And it's based on these 4 viruses I talked about plus a bacterial health, and we're not controlling for bacterial health here. That's the only thing that's going on with us. So if you have really bad bacterial health, you're not included in this. We keep the reds out, even if everything else is negative for viruses. If you're red and bacterial health, we don't include those pigs as negative. We just use the green and yellow groups. So that's when you say pig health, that's what we're talking about. That happens to be a Pipestone specific thing. But if you look at some of these other viruses, well, some of them are viruses and some are bacteria, pathogens, right? I'm showing you here the salmonella culture and the Lawsonia PCR and not the antibody testing because I didn't have a chance to look at the vaccine status for those. And if you remember my talk yesterday, I said the salmonella vaccine covers cholera suis and typhimurium. So just make that correction here now. So we haven't teased that apart. So I'm only including the antigen testing for those. But then you have PCV2 and influenza and MHIO and PDV. And look at this. I did something wrong. Oh, whew, it's better. Okay. All right, so look, influenza, 87.5% have antibodies at the end of growth period. And it was presented by Monsitor Morel that we placed 74% of them negative. 74% are placed negative, and all of these we know are placed negative because we selected them for that. And at the end, 88% have antibodies for influenza. And I double-checked with Kent Doolittle with IDEX. I'm like, that, right? I'm not insane. That's not going to be any maternal antibodies. Those should be way gone, right? And I just confirmed that he's like, absolutely. I'm like, okay. That's exposure. That's a huge amount of exposure. I can't do much statistically because that gives me a very small n on one side of that equation. And then for MHIO, we had 7 positives, but 4 of them were suspect, and we hadn't quite teased them out. So positive. Are they really positive, or are they just suspect? I don't know. 3 were definitely positive, 4 were suspect. So take that 7 with a grain of salt. The PEDV is quite low. The Salmonella is about 66%. Lawsonia is about 64%. There's not a lot of significance with biosecurity at this point for any of these. And that might be true because we place them with Salmonella and Lawsonia. I don't know. We don't test. I have no idea how they're placed. I have no way of confirming that. But we do see that with influenza, biosecurity is protective. And take it with a grain of salt. Right now it seems like for M. hyo, biosecurity is not protective. But if I take out the suspects, that could be very different. So I don't know. I'm not so confident in that result at this point. And my sample size is 7, right? Like one side of that equation is 7. That's not great. So, oops. Wrong way. So I looked at influenza status instead of M. hyo. So that's all I'll say about M. hyo because I just don't feel confident in our designation at this point. But if you look at influenza, the reason why there's no statistics here is because I have an N of 2 right here and an N of 4 right there. So you can't do statistics on an N of 2. You can barely do statistics on an N of 4. So they're too small. But what you see is that trends suggest biosecurity is protective in the finisher and mixed in the nursery. So the nursery, again, has some issues where biosecurity may not be protective, but the overlap is where biosecurity is protective is in regional pig source density, feed mill biosecurity, feed transport biosecurity, and truck and trailer wash biosecurity, and power washing. So there are areas where it seems to help, right, where we know it's going to help. And we come back to the truck and trailer biosecurity and regional pig density have now shown up in multiple places. So in summary, where we're at right now is the nursery side's confusing. Maybe they're not getting infected in the nursery, though. That might be the reason, right? So maybe to extrapolate to the nursery is inappropriate. Maybe they're getting infected on their way to the finisher. I really don't know. But overall, finishers had greater biosecurity and all in, all out, and ages on site. Nurseries had greater biosecurity in truck and trailer wash biosecurity, mortality removal, and power washing. These components were protective against PRRS, the initial pig health, truck and trailer biosecurity, regional pig density. These components were not protective in the nursery. Don't know why. Like I said, could be the issue. And then swine influenza, we had very small numbers, but there was some overlap in areas that were protective, but there were more mixed results in the nursery. It was very clear, the protection and biosecurity in the finisher, but very mixed results in the nursery. So, and I already talked about mycoplasma. So that's where we're at right now. This is just very preliminary. We're excited to see where this goes and see what the costs associated with this is and see if this, as we add more samples in and get more power over the next 2 years, how we'll pan this out. A bunch of references, and of course, thank yous. Schick and Borger Ingelheim are funding this project. Roy Edler is my compatriot that we work on this hand in hand. We work with some folks from our farm stats team that we really appreciate, Kendra Burkett and Shawnee Feldhusen. And then we have an amazing group of veterinary PAs or veterinary technicians who do all our sampling and have been fantastic. They get the treatment records, they do the questionnaire, they do a lot of the assessments, and they get all of our samples. And then there's, of course, we appreciate the veterinary diagnostic lab, and we're going to be working with Lance Mulberry, an economist, to kind of piece this all together. So, oh, and I should say BI helped us put together a lot of this plan and this study design. So Amanda and Fernando and Reed Phillips and Aaron Cavan and Eduardo Fano, when he was working with BI, we stole him. He now works for Pipestone, so that was like our win. But yeah, so that's it, unless you have any, if there's time for questions.
Sure, thank you, Karyn. That's really exciting work, and I think it just brings home the point that biosecurity is complex, and we still need to take a holistic approach to it, because there's no one thing I think that we've identified yet to date that is going to be the smoking gun or the silver bullet. And so we do have a time for one quick question. Yes.
Thanks for the presentation. Very good job. Do you think the difference or the fact that you find that the truck wash was protected in the finisher but not in the nursery is due, or is it because, or highlights the role of the slaughter plant as a source of infection for finisher, and the fact that the nursery does not have the contact with that?
Yeah, that would be my biggest hypothesis. Like, talk about network analysis and nodal spread. Like, where is your greatest collection point of exposure. It's probably at the slaughter plant and then spreads back out. So I would think that has something to do with it. Can I prove it from this data? No, but I think that would be one of the larger hypotheses to go from, because the nursery might go to 2 finishers, but how many trucks go into a slaughter plant every day and potentially expose that truck that then goes back and gets more pigs? And
Great. Thank you, Karyn. Let's thank her again for a wonderful presentation.